Now we proceed the second subtopic in electrochemistry 3.2 about the Nernst equation. This is the learning outcome for subtopic 3.2 Nernst equation. In this video, students should be able A. Write Nernst equation for a given galvanic cell, and B. Students should be able to explain the factor that affect cell potential. So, what is the Nernst equation? Nernst equation can be used to calculate the E cell for any chosen concentration. This is the general formula for the Nernst equation. E cell stands for the cell potential, E naught cell stands for the standard cell potential, R constant, T temperature, and number of electron, F Faraday, ln concentration of product, the power of coefficient, divide with concentration of reactant, the power of coefficient. At standard condition, temperature 298 Kelvin, constant R equal to 8.314, and the constant of Faraday equal to 96500 Coulomb. So if you substitute the value RTF in our general formula Nernst equation, so you get the value 0.0257. And if change the ln to the log, so log time with the 2.303. If time between 0.0257 with 2.303, so you get the value 0.0592. This is the new Nernst equation after you convert R, T, and F and change ln to the log. For your information, concentration product divided with concentration of reactant equal to Q. Q stands for the reaction quotient. Finally, we have the new formula for the Nernst equation. E cell equal to E naught cell minus 0.0592 divide N log Q. E cell stands for the cell potential, E naught cell standard cell potential 0.0592 divide N stands for the number of electrons are involved, and log Q. Q stands for the concentration product divide concentration of reactant. What is the factor that affects cell potential? To study the effect of the cell potential, student must see the general formula for the Nernst equation. This is the factor can be affect the cell potential. First, concentration of the reactant. Second, the concentration of the product. And third, the factor of the temperature. Based on general formula for the Nernst equation, to increase the value of the cell potential, students must be alert have the two parts. Part number 1, this one, and part number 2 for this region. First, student can be increase the concentration of reactant. If the concentration of reactant increase, the value of E cell become increased. Number 1. Number 2, decrease the concentration of product. If concentration of product decrease, the value of cell potential become increased. Number 3, lower the temperature. If temperature decrease, the value of cell potential become increased. Number 4, increase the value of E cell by using the different half cell. If half cell if more negative reduction for anode and half cell more positive reduction potential for cathode, the value of E naught cell increase, automatically the cell potential become increased. Now we proceed the third subtopic in electrochemistry 3.3 electrolytic cell. This is the learning outcome for subtopic 3.3 electrolytic cell. In this video, student number 1 should be able to draw an electrolytic cell. B. Can be described the operation of electrolytic cell. C. student can be explained the influence of the factor on selective discharge of a species at the electrode. And F, student can be state Faraday law of electrolysis. What is the electrolysis? Electrolysis, a chemical process that uses electricity for a non-spontaneous redox reaction to occur, can be concluded in electrolysis from electrical energy generate chemical energy. Different with galvanic cell or voltaic cell, in galvanic cell, chemical energy generate electrical energy. How the component and operation in electrolytic cell? An electrolytic cell is an electrochemical cell that undergoes a redox reaction when electrical energy is applied. In electrolytic cell that have the consist of two electrodes, anode and cathode, immersed in an electrolyte and connected to a source of direct current. This is the diagram for electrolytic cell. In electrolytic cell, we have the two electrode anode, sign positive, oxidation process occur at the anode. Other side, electrode cathode, the sign of negative, the reduction process occur at the cathode, and two electrode dip into electrolyte, and two electrode connect with the source of the direct current, and we have the emitter. Student must be remember, in electrolytic cell, we have the source of direct current. In electrolytic cell, battery is often used. The function of source of direct current will force electron to flow from the anode sign positive to the cathode sign negative. Same concept with the galvanic cell, electron flow from the anode to the cathode. How an electrolytic cell operates? At the anode, direct current source supply electrical energy to force the reaction to occur. During the reaction, negative ion from the electrolyte attracted to the anode, so the process of oxidation occur at the anode with half reaction loss of electron. For the cathode, electron travel through the wire from anode to cathode. During the process, positive ion from the electrolyte attracted to the cathode, so reduction process occur at the cathode without the half reaction gain of electron. Ion are said to be discharged at the electrode. This is example for electrolytic cell diagram. Student can be seen at the anode, sign of positive, at the cathode, sign of negative, so electron flow from the anode to the cathode, and at the anode, oxidation process occur, half reaction of reaction, loss of electron. At the cathode, reduction process occur, half reaction, gain of electron. This is different between voltaic cell and electrolytic cell. Student can be seen at voltaic cell or galvanic cell, spontaneous reaction generate electrical energy, and at electrolytic cell, electrical energy to derive non-spontaneous reaction. And the second, at voltaic cell, electron generated at anode, so anode the sign of negative. At electrolytic cell, electron removed from the anode, so anode in electrolytic cell the sign of positive. And third, electron consumed at the cathode, so cathode in voltaic cell sign of positive. At electrolytic cell, electron supply to the cathode. The cathode at electrolytic cell the sign of negative. In voltaic cell and electrolytic cell, electron flow from the anode to cathode, but different for the anode the sign negative to cathode sign positive, and at electrolytic cell, electron flow from the anode sign positive to the cathode sign negative.